Hello, everybody. Today, we'll go into the very first topic of the linear algebra and geometry. This is the very first part of our math course, and it is matrices. By the way, matrix is a plural form of the matrix. So a singular form of this word is matrix. Okay. So usually we denote matrices using capital letters A, B, C. And when we are talking about matrices, we mean usually the special math object, which is a rectangular array of numbers or some algebraic symbols or mathematical functions. Provided that such arrays are added and multiplied according to special rules. So if A capital is a matrix, we denote matrices using parentheses and put inside of these elements of the matrix. I denote they like A11, A12, A1n, and elements here. A21, A22. So here I skip the columns to n, and for example it can be an1, m1 for example, a m2, a mn element. So when mathematicians are talking about matrices, they mean such object like here we have a capital or this denotion within parentheses, and here elements of the matrices denoted as A small and some indices. For example, ij is an element of the matrix and ij identifies number of rows and j number of column. There the element of the matrix is located. So ij, they define location of the element A within matrix. Column. Also one term, it is the size of the matrix. Size of the matrix. The size of the matrix. It is usually we use for denotation of the size. These euro the notation m by n. For example, for this particular matrix, it means that this matrix has m rows and columns. Number of rows of the matrix and n number of columns of the matrix. And now we are ready to make some examples based on this short explanation and definition of the terms. For example, A is a given matrix and it consists of elements, some numbers, 7. So the size of this matrix you can define as 3 columns and 3 rows. 3 rows and 3 columns, so it is 3 by 3 matrix. For example, the element 3, 2, it means that this element is located at the third row, 1, 2, 3, and second column, so it is 6 here. It is 6 has position 3, 2, so it is 6. This is the first one example. The second example, for example, matrix B equal 1, 2, 3, 4 elements, and for example, the size of this matrix B equal 1 row, 1, 2, 3, 4, 5 columns, so 4 columns. So this is 1 by 4 matrix. For example, I want to know the element B small, 1, 3. First row, third column, so it is 3. Also example. C equal sine x cosine x squared sine x plus cosine x minus 1 over x. For example, ln x cube sine squared x 1 x plus 1, for example. So instead of numbers, we have here as an entries of the function or elements of the function, we have here some matrix, some function sine x, cosine x, etc. Anyway, size of this matrix, to define size of the matrix, see, we have to make the same thing as we performed before. We have to calculate number of columns and rows. So we have here 3 rows, so it is 3 by 1, 2, 3, 4 by 4 column. So the size of the matrix 3 by 4. 3 by 4 number. For example, if you want to know C, for example, 2, 3, it is the second row, third column, 1, 2, second row, 1, 2, 3, third column, it is minus 1 over x. Okay, so I think it's very clear, and now we are ready to continue our work on matrices. Next, our part, I want to dedicate to the operations on matrices. Operations on matrices. on matrices. So, as I said before, a matrix is a rectangular array of numbers or some symbols or functions, provided that such arrays are added and multiplied according to certain rules. So it means that we can use some algebraic rules when we are working on matrices. So, the first one, this third one concept is equality of matrices. Equality of matrices. So, matrix A supposed to be equal matrix B if and only if when for each I and j A with indices ij equal B is indices ij. Now it's clear that their sizes are equal to. So if you have A matrix 2 by 2 and B 3 by 2, you can at a glance recognize that these two matrices, they are not equal. This second one thing, multiplication by a scalar. Multiplication by a scalar. Which is there some number. I do not like lambda, for example. So if you multiply some number or some scalar by matrix A, you have matrix B, so that each element Bij equal lambda times ij. So it means that if you want to multiply any matrix by a scalar number, you have to multiply each element of the given matrix. Example here. Lambda equal, for example, 2, A equal 1, 2, 3, 4, and I want to know B, which is equal lambda times A, and I don't know, I want to know this matrix B. So matrix B equal 2 multiplied by 1, 2, 3, 4, and I have 2 times 1, 2 times 2, 2 times 3, and 2 times 4. And you have 2, 4, 6, 8 matrix. So you can notice here, then sometimes it's kind of a very useful thing. You can factorize your given matrix so that you can take beyond the matrices parentheses this number. Here we continue our work operations on matrices. You can have here example of your matrix A equal 2, 0, for example, minus 2, 3, and your scalar can be a function sine x, for example, and the target matrix B equal lambda times A, and that is matrix is unknown, so very easy to calculate. B it is sine x times 2 0 minus 2 3, and since that you have to gain your target matrix B, you have to multiply by sign each element of their given matrix, and you have something like 2 times sin x times 0 sin x minus 2 times sin x and 3 times sin x, and you can write down this answer like 2 sin x 0 minus 2 sin x and 3 sin x. So no problem if you have instead of lambda or scalar any function. Okay. So next one, operation. Operations. The sum of the matrices. The sum of the matrices. Here we are limited or restricted with the sizes of the matrices. If you multiply by scalar, there is no any other demands to the any demand on the matrix. But if you calculate sum of the matrices, you have to check firstly the sizes of the matrices. So if A and B, they have the same sizes, so sum of these two matrices, I do not like C equal as A plus B, is called as a sum of these two matrices if any element of each element of matrix C, I do not like Cij, equal as a sum of the corresponding elements of the matrices A and of the given matrices and A and B, Aij, Bij. Example here. Example. A equal 2, 3, 4, 5. C equal 1, 2, 6, 7, for example. So the sum of these two matrices A plus B, I do not like C, equal 2, 3, 4, 5 plus 1, 2, 6, 7, and here we have 2 plus 1, 3 plus 2, 4 plus 6, and 5 plus 7. And finally we have 3, 5, 10, 12. And this is the result of the matrix of the summation. For example, you have A equal 5, 2, for example, and B equal, here we have B, what's B? B equal, for example, 1, 2, 2, 2. And if I want to calculate C equal A plus B, you can notice that this matrix has size 1 by 2, 1 row, 2 columns. Here we have 2 by 2. So we can say that these two matrices have different sizes, since that it is impossible to add them. So the sum doesn't exist. Okay, next our work.